Let's talk about pre-algebra. Can everyone see the PowerPoint? I assume just get a nod. Yep. Okay. Got that finger up. You like my Batman answer for quiz 1? Yeah, I am a huge comic book geek. You guys will find that out. Mostly DC. I don't think I have most of my stuff. The white boxes you can see behind me are just part of my comic book collection. I've got some in a lockbox because I have the Amazing Spider-Man 1. And that is definitely in a lockbox because that's in the 5 digits for value. So I'm not giving that one up. I don't care if it's 5-digit value. That one's sentimental to me. I have a couple signed comics from Stan Lee too that I would never give up. But I love Batman comics. I love the whole Bat family, so I have all those. But yeah, I'm a huge DC buff. So you'll find quickly a lot of my questions will have either DC characters in them or Marvel characters. I use them as names because that way I don't have to use my original patient names. Yeah, sure, I can talk. I can mention blood flow restriction probably. It's not a problem. I'll talk about it. I don't believe in it is pretty much it, but we'll talk why. There's some science behind why I don't believe in it. It's not just, I think it's stupid. I do that too, but all right. Why did I not change the heading there? Sorry, I did not change the heading. That was probably because I worked on this late at night. We're going to talk about absolute values, combining math operations, and pre-alg. So first thing we have to talk about when we're talking about this stuff is absolute values, because this is absolutely fun. All right. Absolute values is nothing more than asking how far away from the 0 place is this number, right? So we have that wonderful, if you remember back to elementary school, we have the number line, right? And here we have 0. Here we have all our positive numbers. Here we have our negative numbers. That's a 3, I promise. My neighbor is pounding on my roof for some reason. I guess I'm being too loud. I missed 2. That was good. I teach math. But when you see an absolute value, which is what the straight brackets around something mean, what that literally means is how far away from 0 is 4. That's going to come into play when we deal with moving stuff around in algebraic equations and stuff like that. So 4 is obviously 4 spaces away from 0. That's why it's 4, right? -4 is also still 4 spaces away. It's just 4 spaces to the left versus 4 spaces to the right. And if you ever forget which hand is the right and which hand is the left, just hold them out palms away from you. The one that makes the L is the left. I've actually had to explain that to patients before. That's kind of sad. Like, which is my left hand? Oh my God. Please no. So absolute value is just literally asking how far away things are, right? So if you had a question, I don't like red. Let's go with purple. That was like -3 absolute value. Well, the answer is 3 spots away from 0. I cannot write 3s today for some reason. You know, even if you had something like, it was like the absolute value of 12,600. The absolute value of that is 12,600. That's how far away from 0 it is. Scroll, please. Thank you. So important when we look at what happens when we add and subtract numbers and multiply and divide numbers and stuff like that. So if we add 2 positive numbers together, if you take 2 positive people and you put them together, you have a lot of positivity, right? So it's going to be a positive outcome, right? If you take 2 negative Nancys and you put them together, you're going to have a lot of negativity, right? So you have a negative number. If you multiply 2 positive numbers, anytime that you multiply everything that's positive, it stays positive. Multiply 2 negative numbers. Here's the interesting thing. If we multiply negative people in a bunch, eventually it'll become positive, right? So counting up kind of looks at this. Dividing 2 positive numbers, we have the answer is positive. Dividing 2 negative numbers, the answer is positive. So a lot of times we end up positive. When we end up multiplying 3 negative numbers, well, now we've got negative to positive to negative. Now we end up negative. I'm not going to make a lot of really difficult questions like this because it's kind of rare that we have negative numbers in physical therapy. We're always trying to look for positive. So don't freak out totally. If we add a positive to the negative or vice versa, so we add a negative to a positive, the answer will be relative to the highest absolute value. And what that means is if I have a 2, like I'm looking at 2 plus -1, because the 2 is the larger, the positive number is the larger of the 2, my answer is going to come out positive. But in the second example, we have 2 plus -4. The absolute value of that -4 is the larger, so we're going to end up on the negative spectrum, right? So what we're doing here, if we go back to that whole number line, right? So here's 0, 1, 2, there's 2, 3, 4, 1, 2, 3, 4. What it's literally saying is if we have 2 and we take 4 spaces away from it, we're going to end up over here at -2. We're going to go 4 spaces to that left. This 2 plus -4 is nothing more than saying 2 minus 4. And we know that if we do that, it's going to be a -2. It's just paying attention to what you're looking at, right? The larger of the 2 when we're doing addition or subtraction is going to help us. What happens if instead of this, I say 2 minus -4? What happens there?
It equals a positive. You just draw the line through and you make it.
Yep, exactly. So this, really what happens here, I always think about is we flip this vertical and this becomes a positive. That's the way I always thought of it. It was my stupid way of thinking of it. Really what this is literally saying is 2 minus -1 times 4. We have 2 negatives, becomes positive, right? Again, I'm not going to give you that complicated of questions for math. This is not, this is not figuring out the theorems of mathematics. If you know this stuff, you're good. Again, use your calculator, check your answers. Multiplying positive by negative or vice versa, right? If you're multiplying a positive number by a negative number, it's going to come out negative. Dividing negative by positive or positive by negative, it's going to come out negative. Again, these are just simple math theorems. This is where I start losing people usually, because everyone sees exponents and starts freaking out. Like, I don't like the little numbers. Well, then don't use little numbers and use a little hi-hat, right? All an exponent is saying is a number multiplied by itself a number of times, right? It's the base, which is the number we're handling, right? So in this 2 squared, that's the base, that's our exponent. And just remember, it's all about the base. Got a couple chuckles, I appreciate it. Can be written a couple of different ways when we're talking about exponents. It can be written 2 with 2 in the little superscript. This is typically the way you'll see it on computers a lot of times, which is 2. I like to call that hi-hat 2, but that hi-hat means raised to the power. I looked last night to see if that actually had a name, and I didn't find that it actually has a name. So I like to call it hi-hat. That's what I'm going to call it from now on. Right? 2 raised to the second power. It can also be the same as 2 times 2, right? Which is also the factored form. So 2 to the second power is 2 times itself. So 2 versions of 2. If I say 2 to the third power, all that means is 2 times 2 times 2. 2 to the 100th power means I'm going to go 2 times itself 100 times. We're not going to get that one. That's way too much work for me. Just saying, right? You can be pretty much guaranteed that if you're going to have problems on your test, and it's not because I'm lazy, it's just because writing test questions on Blackboard are hard, it's going to be like maybe something to the max of a 4th power, right? So don't totally freak out. But even 2 to the 4th power you can do, because it's the same as saying 2 times 2 times 2 times 2. There are 4 2s. Boom, 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 boom. And you just extrapolate it out. It's really not as hard as you think, right? So here we have 3 raised to the 3rd power. That's saying the same as 3 times 3 times 3, which is 9 times 27, or 9 times 3, which is 27. There's some simple rules to this too. Any number raised to the 1st power is the same number. That seems pretty obvious. This is literally saying 1, 2. Well, yeah, that's 2. Thanks. I don't know why we even have to have that, but some math genius decided we needed to have that. Any number raised to the 0 power is 1, with the exception of 0. 0 raised to the 0 power is 0. 0 raised to the first power is 0. Let's do a quick math problem here. Let's see how a bunch are paying attention. What is 0 raised to the 256th power? 0, yeah, right? That's not a hard problem because that's like saying 0 times itself 256 times. And we know that's the way it works out, right? So that would be an easy question on a test. If you see it's 0 raised to a power, better pick it. It's a pretty simple one. This is where it gets a little freaky deaky. If your exponent is a fraction, that means you're rooting the number then. And not like, yay, 2. That's not what rooting means, right? It's basically asking you to factor the number. So here we have 4 raised to the 1/2 power is the same as saying 4, the square root of 4, right? I have one written down here in this format, right? It's the same as doing that. Right? Because even though we don't write the 2 there because that's one of the ones that's assumed, I don't know why, math is weird, but that's what that's saying is it's saying how many what factored twice equals 4? Well, 2 times 2 is 4. So 2 is the square root of 4 because 2 squared is 4. We have cubed roots, we have 4th roots, we have 5th roots, we have 6th roots. But again, most times in physical therapy, at most, you might be dealing with a cube root. And that's only when we're talking, about like cubic centimeters and stuff like that. So don't totally freak out about this. Get the hiccups now. On your test, I can guarantee pretty much for me at least, and again, not necessarily for your boards because your boards aren't going to have any of these. On your test with me, I probably, the most I'm going to go to is the 3rd root. So like here we have 81 squared, or 81 to the 2nd power. That's here, right? Maybe I might do 27 to the cube root, or 27 to the cube root of 27, which is nothing more than 3 times 3 times 3. We already did that, which means the answer is 3. Your calculator should have it. Even if you have to bring up your Windows calculator, you bring up your little Windows calculator. In the upper left-hand corner of Windows calculator, there's a section that says change to scientific. Change it to scientific, and you can do all of the math problems you need to do. If per se you need to do something that's not showing there, maybe you need to raise a number to the 4th power and your calculator doesn't have to the 4th power. There's a little button that says second on it. Second brings up additional methods on your calculator. And a lot of time there's one that'll say y to the x power. You type your first number in, hit y to the x, hit the next number, it'll do the math for you on your calculator. They never taught me that in school, and I was really mad when I figured that out. So like your calculator might say something like, it'll say, or x to the y power. If you put in 3, that's going to be your x, and then you hit the x to the y power, the next number you put in will be your exponent. Most calculators will take fractions too, so you could even put half if you wanted to. In this case, right, I have 81 to the 4th power. That's the same as saying 81 with the little thing here. That's 3, because 3 times 3 times 3 times 3, man, I can't write today. I think I'm having a seizure. Times 3 is 81. There are 4 3s. The 4th root of 81 is 3. If we did 81 to the 3rd power, it'd be a weird number because there's not a number that goes 3 times evenly into 81. So you'll end up with this weird 4.326789444. So just keeps going, right? I'm not going to give you one like that. I'm going to make sure that the questions I give you either go out to that number or unsolvable.
Mr. McKeever?
Yes.
So we don't do anything with the 1?
You mean the 1 on the fraction?
Yes.
Yeah, no, all that's basically saying is you're flipping it into that little symbol there. That's
Okay. Will it ever be like 81 to, I don't know, like 2/3 or something like that?
okay. So will it ever be that way? Not in real life.
Okay.
Not in real life will it ever be that way. If you're taking higher level math, yeah.
Yes. Okay.
And then you're talking about parabolic equations and the way to solve it. I'm not teaching you that. That's just way too high. If you want to go take a course on that, go right ahead. You're following in my footsteps. But no, it's always going to be a 1 up there.
Okay.
I'm not going to make anything more difficult than that. I'm trying to keep, I am really following with math, the KISS policy. Keep it simple, silly, right? Some of you may know this at final S as something else. We had a different term for it in the military. I'm not going to say what that term was because that would be a bad word. But I'm going to keep it pretty simple because I'm trying to teach you in math what's required by Department of Education so we can kind of get onto the stuff that you need for math and physical therapy. So keep it simple, silly. We're just going to stick with that. So parenthesis can be simply seen as multiplication in the most basic form, unless it includes parenthesis followed by an exponent. Then you have to complete what's in the parenthesis and then do the exponent. That's, again, a lot higher level. I'm keeping it pretty simple. So in this case, if we have 3 in a parenthesis and a 3 outside the parenthesis, the same as saying 3 times 3. Both 3's in parentheses, 3 times 3. In this third example here, we have something inside the parentheses and then something outside the parenthesis. What that's saying is we complete the stuff in here by order of operations and then multiply it times what's outside. Even if we had something as complex as like this, that's a pretty complex equation. But that's nothing more than saying this. This is just multiplying. That's all it is. We're not going to solve for multiple variables, so don't totally freak out about that. You're not gonna have something hard like that. We're not doing multiple variables. We'll talk about the quadratic equation when we talk about linear lines, but even that, we're keeping it as simple as possible. We're not going to figuring out how to calculate parabolics on it and stuff like that. So what I'm saying here literally is when we have parentheses, nothing more than multiplication. Why do we have to know this? Because of order of operations. Before we go into pre-algebra, we have to understand that order of operations. I hit it in the first lesson, gonna hit it in the second lesson. Parentheses, exponents, division or multiplication, whichever you like. I like doing things alphabetically. So I do PEDMOS. If you want to do it PEMDAS, fantastic. Multiplication and division are the reciprocal of each other, so it's all academic here, right? Exponents and parentheses are the number one thing that make people make mistakes in math, because you either forget it or you'll see an exponent and multiply. I've seen this before where somebody will be like, let me see. So we've got 2 here, 2 to the 4th. And they'll go, oh, that's the same as 2 times 4. And it's 8, right? That's 2 times 2 times 2 times 2. So don't let exponents mess you up. I've also seen people where they've got something simple like, which I think is simple. Something simple like this, which is a fairly easy question. But somehow, as soon as they see this, their mind just goes, oh my God, there's a letter there. And their head explodes. Where else you have to do is solve inside your parentheses, follow your order of operations. 3 minus 2 is 1, right? So now you have 1x equals 1, which means x is 1. Right? It already tells us this can actually go away. You have your answer, x equals 1. So don't let order operations mess you up. Don't let parentheses and exponents mess you up. You're not going to have a ton of questions on this because in real life physical therapy, we don't deal with a ton of this, right? We don't do square dancing in math. It's not something we do, right? We will deal with a little bit when we're talking about waveforms in modalities. But in reality, you're not really that. Yes, it's good to know why a biphasic waveform works the way it does. But it's more important to know how that works than why it's the way it is. Does that make sense? Oh, well, this makes a patient feel better because it works on this nerve. That is by far more important than understanding that if you look at this formula, it's literally saying x squared equals 2 and y squared equals 3, and that's how you get these waveforms. No, I try to keep this stuff simple. All right, so we've got one here. So we've got 4 plus 3 times 3 minus 7 to raise to the second power. I put this on your test. Most people are going to absolutely have an aneurysm and freak out. But again, I'm going to tell you, and this is true. If you ever have any, do you ever have any of those friends that post these questions up on their Facebook? They're like, only 5% of the people can solve this problem. Blah, 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 blah. Just plug it into Google. Somebody solved it already. Literally, you could take this, you could copy this whole equation. You could come in here and just go, copy. It is so annoying. You're exactly correct. You could copy that whole section, paste it into Google. As long as you have that equal sign after it, Google will solve it for you. Or it'll say it's unsolvable, which is possible because some of them are. I love arguing this because there's usually that one person that thinks they're smartest and they think they know the answer and their answer is wrong. Right? That's always that one person. It's like, my answer's right. No. Your answer's wrong. And here's why your answer's wrong. I had a comment about that with somebody about masks yesterday. That drove me nuts. Anyway, so following order of operations. Our first order of operations is completing the parenthesis, right? PED-MOS. So let's get rid of our parentheses. We know that 4 plus 3 is 7. So we've now gotten rid of this inside here. Our next order of operations is exponents. Let me change that color. Exponents. Here we've got exponents. 7 raised to the second power is 49. We've gotten rid of that. Now what our problem literally says is 7 times 3 minus 49. Well, we know that division and multiplication is next, so we need to get that 7 times 3. Got 21. And then we just do the final part, the subtraction. 21 minus 49 means the answer is negative 28. When you step it out like that, it does make sense, but it's just when you see that initial question, for whatever reason, your brain just goes, ah, like Home Alone, ah, right? Whereas if you just calm down and look at it, go, okay, let's break this down into chunks. If I break it down into chunks, I can do it. It's not any different than your logic you're going to have when you solve a question that you don't know the answer to, right? You guys learned that back in like English in 5th grade. If you don't know the answer to the question, you break it down into context clues. The PED-MOS is context clues for math. I know I say it's simple, and I know some of you are going, it's not really that simple, Mr. McKeever. It really is. If you let yourself get all freaked out about it, no, it's not, right? Same thing's going to happen when you come to your board. You're going to get a question, you're going to on your boards, and it's going to be talking about the production of acetylcholine in whatever part of the brain, and you're going to be like, I think I just had my brain. It just break down the question. Same thing here. Break down this question. So now we get into the pre-algebra, the fun things. We start talking about variables, right? Variables are nothing more than an unknown number. It's the same as doing a math problem, solving for an unknown, but you're now just putting a letter there. I always like this. This is one of my favorite phrases from math is, dear algebra, stop asking us to find your x. They're not coming back, and don't ask why, right? It's true. For whatever reason here, we'll have a word problem that's something like this, where we're talking 4 minus what equals 3. If I write the problem out like this, your brain is fine. I put an X in there and suddenly your brain explodes. I don't know why that is. I'm sure that there's some science behind it. I don't know what that science is yet. I really got to look at that from a psychological standpoint. I don't know why it makes your brains explode. Because here you can go, oh, what minus 4 equals 3? Well, that's obviously 1. All you're doing down here is you're just solving for x. Same thing you do up here. It can be any number of letters, P, T, X, Y, S. Certain letters are avoided. A, B, C are usually avoided because we usually talk about those when we're talking about angles and positions and stuff like that. And does anyone know why we don't ever use I as a variable? Does anyone remember that from math?
Doesn't it mean like an imaginary number or
Yes,
something?
I is the imaginary number, yes.
Okay.
Only would we ever come up with this that we have to have imaginary numbers, right? This is like going back to Bert and Ernie's school. We have imaginary friends. And typically the imaginary number is actually a script I, right? It's not just I like this. And it's not I like this. That's a totally different thing. That's part of your body. Right? But I is the imaginary number. And what I really is the square root of -1. You can't do that. That's a math inequivalency, right? You can't do that. So they made up an imaginary number for it. And there's all kinds of theorem why they do that, and it's a headache. If you actually study that, it really becomes a headache learning why they did that. And it was for solving specific equations of theorems, right? The neat thing about science and math is we learn things every day about both, right? That's why I always, have you ever had this person that says that a fact isn't a fact? Your facts don't matter, right? You give them a fact and like, well, you're basing that on a guess. You're absolutely right. I'm basing it on a guess, right? Science is nothing more than proving guesses. Math is nothing more than theorems of math. Tomorrow we could find out that really 5 equals 3 because we made some mistake years ago and now the math has changed. It happens. That's the thing about science and math is it's never a static concept. Like gravity. We know that gravity's constant is 9.8 meters per second squared. If the poles change even slightly, that gravitational constant will change. And it may become 9.5 meters per second squared. Well, if we don't change, we're not doing the math right, and we're not doing the science right. But people will say, well, because you made that change, it proves that your facts are invalid. Right? Because if you look at history with math and science, you know, thousands of years ago, we know the gravitational constant was around 10.1 meters per second squared. It's now 9.8. Well, the poles have shifted, we've tilted, our gravitational is different. So flat earthers will use that as an excuse to say that gravity doesn't exist. And we're going to have fun talking about things like flat earth and physics. That is going to be a blast. I hope none of you are flat earthers. If you are, we're going to not have so much fun. I hope none of you believe that. Yes, and for those that don't know, there are people that believe the earth is flat. I'm not joking about that. They had a convention here 2 years ago. I went to it. My head hurt. And literally, I pretty much felt my brains oozing out of my ear. There's dozens of us. You know what the best part is? Flat earthers gather all around the globe. There are some really weird people that are flat earthers, guys. Kyrie Irving from basketball is a flat earther. The rapper B.O.B. is a flat earther. It would not surprise me to find out that Don Jr. is a flat earther, but that's beside the point. So we can use whatever, you know, if you don't like X because X gives you bad memories of your X, use a different letter. Doesn't matter. It's just a variable. That's all it is, right? I tend to use S, and I never understood why I use S. I just don't like X. I have some aversion to it, but you know, whatever works for you. So coefficients are numbers that go with variables. So in case here, we have 13x. 13 is the coefficient. X is the known variable. All that is how many of that x do we need, right? That's what a coefficient really means. If you have a variable that's standing by itself, such as just x, it's the same as saying a coefficient 1 to the x, 1 times x. If you have multiple variables such as xy, it's the same as saying 1xy or 1x times 1y. We just know that the number in front of it, right? This number here is our coefficient. This number is our variable. So if you get a question on your quiz that says, your number shows like this and says, which is your coefficient? The 14 is the coefficient, the x is the variable. Not a hard question to get right. That's an easy one. It should be a gimme. So that's when we talk about expressions. Expressions contain numbers and or variables, but there's no equal sign, right? That means we cannot solve that expression, but we can evaluate it. Dr. Reskin says hi. I don't know why she just texted me, but she says hi. Maybe she's listening in here and I don't know it. So here we have 3 minus x. We have no equal sign over here, so we can't solve it, right? There's just no way to solve that question, that problem, because it's not an actual question. That's just saying 3 minus x. I can evaluate that, right? That's what we do down here. So I look down here and I say, evaluate 3 minus x, where x is equal to 2. And that's what we're going to do when we're talking about linear equations. If x is 2, what does this expression equate out to, right? Or evaluate out to? Well, that's same as replacing this x with a 2. So 3 minus 2, the evaluation would be 1. We can do the same thing with multiple variables. Let's say we have something like this, 2x minus y. Now your heads explode. You've got 2 variables. This is as hard as a 2-variable question I'm going to give you. What I might say is 2x minus y, right? Where x equals 1 and y equals 1. And then evaluate. Now you've got an answer for both your variables, right? So we're just going to replace our variables. So we have 2 times 1 minus 1. So we have 2 minus 1. The evaluation will be 1. If for whatever reason, I'm going to erase this out here real quick. If for whatever reason, I don't give you a y value, and I say, evaluate the equation here where 2x minus y and x equals 1. At that point, you'll replace the variable you know. Right? At that point, your evaluation is 2 minus y, because you can't get rid of y. Why can't you? Because you have no value for it. That's the evaluation of that equation where I haven't given you a variable or the variable y. It's not going to get any harder than that. I'm not going to do like 2x squared minus 3x plus y and evaluate. I'm not going to do that. You can do that. It's just a matter of doing the math, but I'm not going to be that mean for you guys. That there's nowhere in physical therapy we'd have to do that, right? In math, you will, but in the real world, like I think about this a lot because I've had 4 courses of advanced calculus. I have never used any of those skills in real life, ever. I've used simple geometry, right? When I'm building things, I've used simple geometry and stuff like that. I've even used squares sometimes, right? But I've never in my life have I ever found something where I have to do that. It could be with 2 minus y. Yep, you got it. So Riley's right. Right? There's nowhere in life you're doing this. It just blows my mind, right? Now, if you want to take math and learn why, it's great. If you want to go on and get another math, the good news is if you guys do decide to go on for a more advanced degree, most of the times it only requires 1 math class, which is nice, right? But you know, my psych courses required 5 math. That sucked.
Mr. McKeever,
Yeah.
I actually kept going with the problem. I was trying to show my work.
Well, yeah, because we don't have an equal sign, we can't do that yet.
Oh, okay.
Does that make sense?
Yeah.
So in this case, because we don't, if we had something like this, then yeah, we could keep going. If we had that equals 1 or something like that, but we don't have that. So we don't really have anything equal. We're just evaluating it. And again, that's the only time we really do evaluations in math and reality is when we're trying to figure out if a theorem is right. Most of the time we're going to be solving, which is what we're going to talk about next. Why am I just doing that? Why don't I just clear it all? That makes more sense than erasing it all. So expressions can contain numbers or variables, but it doesn't have an equal sign, which we talked about. So here is a word problem for it. A PTA spends $295 on books for semester 1. PTA spends X books on semester 2. What would be the combined money of the books as written as a expression? Well, $295 plus X. We can't solve it because we still don't have an idea what you spent. We don't know how much your total was, right? That would be the equals, and we don't know what X is. So at this point, we literally can't find our X. Some of us would be real happy about that, like me. I don't want to find my X. Just remember that evaluating is not solving because there's no equal sign, right? No matter what I do to you, if there's no equal sign, you can't solve it. If I would put a problem that says 2 minus y, solve. Does anyone know what the answer to that would be? You can't. It'd be undetermined. You don't have enough information, right? Not possible, undetermined. You can't solve it. Anything like that would be, you're going to go down and find the one that says nope, right? Maybe one says nope sandwich, nope sauce. I don't know, something down there. You can't solve that. Even if I would change that and say, instead of saying solve, if now I say evaluate, if I don't tell you what y is, this is the valuation because you can't do any further, right? I'm not going to be that silly, but in math, I've had a professor that did that once. I remember he had this long formula that was literally the whole way across the sheet with no equal sign and said evaluate. And 30% of the class got wrong. The answer was A. It was the same formula. You can't evaluate it. You don't have, now if I say evaluate where y equals 2. Now you can evaluate it, right? Because now you can replace y with 2. And the evaluation for that is the big old goose egg. Notice I'm not saying this equals 0. Literally in math, what you're saying is if you're writing it out in true mathematic form, you say in the equation where 2 minus y and y equals 2, the evaluation would be 0. I'm just going to shake my head and go, that's math. I love math. That's the funny part. It's just sometimes I go, why do we have to teach this again? So solving this equation is going to be, for algebra, that's going to be the majority of what you're going to do for me. And you probably, on the next quiz, we'll have about 4 or 5 of these questions, and they're going to be fairly simple. So when you're doing solving, the main goal is to get the variable on one side by itself by using inverses and standard math, right? Addition is the inverse of subtraction, vice versa. Multiplication is the inverse of division, vice versa, right? So here we actually have it. So now we're beyond evaluating because we have an equals 13. There are a couple of methods of thought here with this question. And I went by the way the book does it first, and then I'll show you the way I would think of this one. So the book says you have to get X alone because you always want your X to be alone. No matter who they are, you always want them to be alone. Right? Isn't that true? No, just kidding. First thing we have to do is we have to get rid of this. I'm going to change my font color here. First thing we have to do is get rid of this 5 because it's on the same side so we can get X by itself. Whatever you do to the left side of the equation, you have to do to the right side of the equation. If you do the same thing on both sides, you're okay, as long as it's the same. So if I subtract 5 from this side, that'll get rid of it, as long as I subtract 5 from the other side, right? What this will really equal out to is negative X equals, right? Because we've got that X. The book really messed us up now that I look at it. Oh boy, book. Oh no, that's not supposed to be a negative sign. Ignore that. That's not there. I hate when these PowerPoints do that. That's what the problem was. Okay. So the problem literally is just X plus 5 equals 13. We need to get rid of that 5 on this side. Subtract 5 from both sides. X is going to equal 8. Let's say if we had the problem like I was saying. So we have negative x plus 5 equals 8 or equals 13. The answer is going to be different, right? We can do similar things. We can subtract 5 from this side, subtract 5 from this side. Right now we have negative x equals 8. What does that mean x is going to equal to?
Can't you multiply both of them by -1 to make
Yep.
it positive?
You can absolutely, right? Yeah. This is what I was going to talk about from my mindset. I'm going to take this a whole different, this is the same as saying -1 times x equals 8. If I want to get rid of -1, I just multiply it by another -1. I'll multiply the other side by -1. Right? And that's the negative sign, I promise. This is why I don't do art. So x equals -8. A lot of people will mess that up though. And sometimes when I think of this, oh, I don't want that. I want the eraser. Where's my eraser? There it is. I make it way overcomplicated for myself so I don't make a mistake. So I'm going to actually erase this whole thing so I can write it a little bit neater. Let me bring up, there's the text box. That'll work. That probably looks a lot neater. So what we have is minus x, right? Plus 5 equals 13. When I'm looking at that, I would much rather get that x over to the other side where it becomes positive. So in my mind, this way is easier. I just added x, right? So I added x to this side. I added x to this side. And then all I have to do is subtract 13 from both sides. And that gives me my -8 equals x. Whatever way works for you, either way works. I just don't, when I start seeing a negative variable, I try to get that negative variable positive as soon as possible. Because that negative variable invariably screws me up. But most of you, again, I am being nice and allowing you to have calculator. So check your calculator. Here's a neat fact I'm going to tell you. Shh, don't tell the instructor, but I can't see if you use Google when you're doing your test. I'm just saying. So if you check your answer, don't tell your instructor about that. So whatever you do to the left side or the right side, you do the left side. Whatever you do to the left side, you do the right side. We'll just look at this one last question, and then I'll give you guys a break for Dr. Johnson's class. So here, and I got to really change that so that that doesn't show up. This is not a negative number here. Ignore that. This is literally saying 3 minus x divided by 14 equals 14. Looking at this from my standpoint, I want to get rid of this. That's annoying. Right? To me, that's just obnoxious. How do I get rid of that? Well, I multiply both sides times 14. I don't know why that line got moved. That'll get rid of that for me. So I have 14 times 14, 196. So what I have is 3 minus x equals 196. Subtract 3 from both sides. I end up with negative x equals 193. Multiply both sides by -1. There's my answer. That is probably as complicated of a math problem as you are going to get. It's not going to get, that's actually pretty hard, honestly, for most of my math problems. I don't know if you guys noticed it, but my math problems aren't exactly like rocket science. I looked at your grades. They're not rocket science, right? That's about as hard as it's going to get. I'm not going to have you solving quadratic equations and stuff like that, because again, we don't do that. You have to have it for your understanding it. That's about as hard as it's going to get in this class. Let's just do one quick more question and then I'll cut you loose here. So let's say we have 13x divided by 21 equals 1/21. What's the first thing we'd want to do to make this problem easier?
Multiply both sides by 21.
Yep, multiply both sides by 21. So I can get rid of this divided, right? This is the same thing as saying 13x over 21, right? I can't simplify that. I would have thought of that maybe. I can't simplify it. Doesn't work. So there's no way of making that easier for me, but I can multiply both sides by 21. If I multiply both sides by 21, that is gone, right? Yay, I got rid of it. So I've only got 13x on this side. If I multiply this times 21, what does that do over here? That turns it into 21 21st, which is the same as saying what?
1.
1. Good. And then what do we have left to do?
Divide by 13.
Yeah, divide both sides by 13. So x equals 1/13. That looks like a really complex problem, but if you step it out, it's not. Right? If you take your time, go through the problem slowly, and work it out, it's not. Why do we talk about this? Well, you guys heard me talking about your grades in the other lesson if you actually paid attention. You may want to solve what you need to get on a test in order to pass the class. You're doing algebra for that. So if you can't do simple algebra, you're not going to be able to do it. And like I said, I'll give you one shot to help you with your grades. After that, I'll confirm if you're right or wrong. I'm not going to help you do it. All right. So we'll come back. We'll do this next question on Monday. We're actually a little bit ahead even. And then we'll start getting in, we'll zoom through quadratic or the actual graphing and stuff like that, which won't take long. And then we'll get some fun stuff. I promise. I do have some fun stuff coming up in math. It's not all this dry stuff. Let me stop sharing here. Are there any questions today? Is there anything on the lesson that I recorded